Hey friends, welcome back to another episode of Sound Advice with sound engineer Barry. In this episode, I'm not planning on talking about sound, I'm planning on talking about lighting and lighting control, demystifying DMX. I've got friends with bands who carry around band lighting equipment to make their show look more impressive and provide a better visual experience. I've got some friends who have party rooms and they have mood lighting in their rooms. And some of these folks have set up their lights to be just in a static situation, so they always put out a particular color, or others will set up their lights to be in an automatic mode so that they just play random patterns and colors depending upon the sound that they hear. And that can be fun. But to get the most impact, to have the most control, it would be great to have your lighting do exactly what you want it to do when you want to do it. And to do that, we can control lights with DMX signaling. Now, sometimes when I mention this, friends will back off a bit and go, "Whoa, Barry, I'm not really a lighting designer guy. I'm not a computer guy. I mean, all that DMX signaling stuff, it sounds kind of complicated." But it's really quite simple. And so I'd like to explain the basics of how DMX works and how you can set it up to get your lights to do what you want them to do. Let's talk a little bit about how we got here. Back in the old days, back around 1900, we started using electric lights to light up theater performances. And when we did that, we would have these big fixtures up in the ceiling, lighting up the stage, and each of the fixtures would have a gel in front of it, which would shoot out a color of red or blue or yellow or whatever. And we may have some of those fixtures gang together, so we'd have multiple fixtures that were red, multiple fixtures that were yellow, and so forth. And then the power cables for those fixtures would come down to a light control board where an operator would sit and he could control the brightness of those banks of lights. So this is a big control board that looked kind of like an audio mixing board with, let's say, 8 different channels of control, 8 big faders on it. And as he pushed up the first fader, that would be channel 1, there was a series of outlets in the back of that control board that would power the lights that were plugged into it. And you could run up and down the voltage to cause that bank of lights to go from off to dim to brighter to fully bright, depending on where you put that control. And the same thing for channels 2 through 8. So we had a whole bunch of power coming into that board, going through these big dimmer controls that would then go out the back side of the board and up heavy cabling up and run the lights. But as you can imagine, especially as systems grew, these lighting control boards became quite monstrous because they were handling an awful lot of power. So we decided there must be a better way. So what we did is we made it so that the control board no longer actually controlled the power, but instead just sent out a control signal that would go up into the ceiling and control the light fixtures through a external dimmer pack. So he'd still have all the faders on his board saying fader 1 through 8, but as he pushed up the first fader, instead of actually driving a whole bunch of power outside the back of the board to run the lights, it would just have a single wire coming out of it that was just a control signal. So that the control signal didn't handle a whole lot of power. It was just a little voltage signal that went from 0 to maybe 10 volts. And so then that thin little control wire would run up into the ceiling and go to a dimmer pack unit, which actually switched the power for that bank of lights. And so the dimmer pack would take in high power on one end and a bunch of high power out the back side, which all the lights were plugged into, and it would accept that control signal on a thin wire. And if the control signal was at 0, because his fader was all the way down, the lights would be off. And as that control signal rose up, the dimmer pack would allow more and more power to go through it and illuminate those fixtures. But as lighting systems grew, that still was a lot of cabling because each channel of the fixture needed a wire running out of the board and up into these various dimmer packs to run the lighting. And so around 1986, the industry got together and established the DMX protocol, which allowed that signaling information to be transmitted on one wire that all of the fixtures could interpret and receive and process. And so in order to do that, we went from an analog system where each wire had a control voltage that would rise up or down depending upon the dim level. It would use the digital signal. And to do that, we just needed to communicate the position of all of those controls on the board. So we have 8 controls on the board for channels 1 through 8, and each control could be all the way down at 0 or pushed up all the way to the top to 100%. Or, could be in the middle at 50%. And we just needed to represent each of those control positions as a number that we could transmit digitally down the cable. And so because of the way that the math works out, we assigned a number value to each possible position of each control. So if the control was all the way at the bottom of the board with the light turned off, we'll call that 0. And if we push the control up all the way to the very top to 100%, we'll call that 255. That's just how the math works out. So we can represent any position on the control as a number between 0 and 255. If the control was about halfway down, about 50% brightness, then that value would be, you got it, 128. So any position on the control could be represented by a number. And so now all we need to do is communicate from the lighting control board to the devices that it's controlling what channel it is and how bright the channel is. And so we just need to send out a stream of digital data across a single wire that just says channel 1, 128. That means the position of the control is halfway up. Channel 2, value 0. That means channel 2 is turned off. Channel 3, 255. And so forth and so on. And channel 3 would be totally turned on in that case, of course. And so all that the lighting control board does is it sends out a stream of data that just says what channel number it is and how bright that control is pushed up. And so it just goes through all the channels and blurts out each one after another on the cable and what its value is. And when it gets to the end, it does it again and starts over with channel 1 is this value, channel 2 is this value, and so forth, over and over again. And it does this about 40 times a second. So about 40 times a second, down the cable is this little digital communication that says what the position of each of the controls on the lighting control board is. And then of course that wire goes up to the lighting dimmer control pack, or the light fixture, and the fixture, or the control pack, interprets that data stream coming in. And the fixture knows what channel it's assigned to. There's some switches on the fixture or some setting in it that says this fixture is assigned to channel 2. And so as the data stream comes in, the data stream says channel 1 is this value. Your fixture says, well, that doesn't affect me, not my problem. It ignores it. Then it says channel 2, value 40. Channel 2 goes, hey, that's me. 40, okay. And it adjusts itself to the brightness associated with a value of 40. And then the communication says channel 3 is such and such, channel 4, such and such. And this fixture just ignores all of that because it's not assigned to those channels. And then about a 40th of a second later, it gets another command, and it makes its adjustment to that level. And so whenever it hears the appropriate channel that it's on, it adjusts to that value, and it just stays there until it hears another command to do something different. And that's how the system works. So it's really quite straightforward. Now, over time, we've gotten into more complicated lighting systems than just simply par lamps that can either be turned off or on or to some value. We've gotten into fixtures that might look like something like this, for example. This is a simple RGB fixture. RGB meaning red, green, blue. And so with red, green, and blue, we can make up any color in the rainbow. And as you can see, it's got positions for DMX in and out cabling, and a series of dip switches that will control the modes of this light, being either, freewheeling with sound. You can set the light to be a particular color, or you can tell the light to respond to DMX signals coming in the cable, and if so, which channel of DMX this light should respond to. But that fixture can do more than just dim. It can control 3 different colors. And so we need at least 3 channels for the red, green, and blue channel, and how bright each channel is. And by adjusting the brightness of those 3 different colors, we can make the light come out with any color that we like. So this light fixture is going to require 3 channels of DMX, or more, depending upon its feature set. And so in that case, on your control board, you might have channels 4, 5, and 6. Those 3 faders right there, where channel 4 would control how intense the red light out of that fixture is. Channel 5 would be the blue light, and channel 6 would be the green light. And so in that case, the fixture would require multiple channels on the board to operate, but by operating those various channels, you can make the fixture do whatever you want it to do. And of course, if I had a second fixture, just like that one, and I plugged it in as well on the same channel, both of those fixtures would do exactly the same thing. They'd be ganged together when you operate the controls on your mixing board, your lighting mixing board. As you can imagine, this gets a little bit tedious to operate as an operator, because you have all of these different controls for each of the fixtures to do different modes, being brightness, dimming, strobe, and so forth. And then we get into even more complicated fixtures like this Martin scanner right here, which can have different colors, different gobos, different mirror positions, and so forth. And each of those features will be attached to a particular channel of DMX. So a fixture like that may, for example, require 7 channels of DMX to cover all of the features that that lamp can do. And each of those channels will operate some facet of that fixture. For example, there's maybe a channel that operates what the position of that mirror motor is, where 0 is all the way on one side and 255 is all the way on the other side. So each of the channels can be used for dimming or controlling various features of the lamps. And of course, each lamp will interpret that DMX in its own way as its manufacturer has designed. So, like I mentioned, it can get a little bit complicated to operate complicated fixtures like that with a lighting control board. Now, so with lighting control board, what you can do, and different boards operate differently, but generally speaking, you can set all the faders on it to create a scene of lighting that you like. You want your band lit up in red with just a little bit of blue on the edges. Push all the faders appropriately to get that scene, and then you can hit a memory button and store that scene in memory for quick recall. And then what you can do is you can create another scene, and you can store it in another memory location, and so forth. And so when you want to recall these scenes, you can just quickly hit a button and boom, boom, and you can recall the entire lighting scene, and all of your fixtures immediately go to the mode that you want them to go to. Then what you can do is you can create one scene that transitions to another scene, save all of those scenes, and you can loop the scenes. So for example, you might want to have everything go red, and then you have some of it go to blue, and then a little bit more goes to blue, and a little bit more, and so forth, scene after scene after scene, and you can set these scenes up in a loop sequence. And then so when you hit run on the loop, it just quickly steps through scene 1, 2, 3, 4, 1, 2, 3, 4 in a looping sequence. And of course, inside of the lighting control board, you can control parameters such as how long to stay on each step in that loop and how fast it transitions through the loop. You can also set up things like, should it jump hard from one scene to the next or kind of fade from one scene to the next. So if the value on a channel goes from, say, 40 to 60, should it just be a command that says 40 and the next one is 60? Or should it, over a period of time, go 40, 42, 46, 48, boom, 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 on up to 60, so the light kind of gradually changes over? You can control parameters like that with the lighting control board, depending upon the lighting control board and its feature set, of course. But as you can imagine, it gets kind of complicated controlling more advanced fixtures with a old school lighting control board. So the other choice is to get an adapter for your computer. Typically it's something like a one of these guys. They come in different shapes, different sizes, but basically it goes from USB that plugs into your computer to DMX that goes out to your light fixtures. And there's computer software from different manufacturers that will allow you to do all of the things that you could do with a lighting board and more. I'm not here to endorse anything in particular, but I'm using software called Freestyler, which is completely free to use, and I think it's a great DMX lighting control program. There are other software packages out there. Most of them are not free, and different software packages are compatible with different DMX adapters. Freestyler is pretty capable and will talk to a wide variety of different DMX interfaces, but make sure that whatever software you use is compatible with the DMX adapters you have. Or you may want to find a software package that does what you want it to do, and then make sure to get a DMX adapter that is compatible with that software. This DMX adapter follows a standard called NTEC, which is a common protocol, and it's made by DMX King. Again, I'm not here to necessarily endorse anybody, but I've had really good luck with DMX King adapters. And this one's about $100. Like I said, the software in my case, it's free to use, so the software's nothing. This is about $100, and then whatever fixtures you want. Mechanically, how you'd set it up is the output of this adapter, which would be the same connector on a standard DMX lighting control board, either way, goes to a cable which looks like a standard microphone cable. If you're lucky and you use good microphone cables, you can get away with that. DMX certified cable is a safer choice. And that cable then goes into the back end of a fixture. Like so. And you'll see that there's another connector on the back of the fixture right beside it, which allows you to extend a cable onto a second or third or fourth fixture and so forth. And if multiple fixtures are assigned to the same address, they'll behave the same and they'll be ganged together. If the other fixtures are assigned to different addresses, they'll respond to their own addresses. But you can chain all of the fixtures together with one DMX cable run. The last fixture in your chain should have a terminator plug plugged into the DMX out connector. And the terminator plug is just simply a 3-pin connector, kind of like a microphone cable connector, that has a resistor inside of it that helps keep the impedance, the resistance of the cable correct, so that the digital signal that gets sent down the cable doesn't hit the end and kind of ring back electrically and create confusion in the signal train. DMX terminators are real cheap, and I highly recommend that you use one in order to provide the best quality DMX signaling so your devices work reliably. When initially setting up your DMX system, my advice would be to get your DMX control board and or the computer software and get one fixture working. And once you have one fixture working, then add a second one and get it working, and so forth on down the line, adding one at a time until you get all of your DMX fixtures operating properly. Because they're daisy-chained together, kind of like Christmas tree lights. And so if you have a failure somewhere, it could impact the line of fixtures. DMX will allow you to have 512 channels of control. And like I'd mentioned, some of these fixtures will operate on multiple DMX channels. And so although 512 channels seems like quite a lot, and it is, if you had simple par lamps, that would be a pretty complicated setup, but with some of the modern fixtures that operate on 5 or 7 or 11 DMX channels, it is possible to consume all 512 channels, so plan accordingly. After you hit that number, you have to run a second DMX cable and another DMX universe. And of course, a fixture cannot straddle two DMX universes. They all have to be controlled by a single controller, a single universe. Well, I hope that demystifies DMX somewhat for you. I think it's a powerful tool that allows you to script out your lighting to create interesting and powerful mood effects, and puts you in control of the scenes that light up your room or your band. And it's not very expensive or difficult. And so I encourage you to explore the world of DMX and have fun, be creative, and subscribe. That'd be great. If you hit the icon down below and subscribed, I'd really appreciate it. Be sure to also hit that bell icon so that you get a little email notification from YouTube when there's new content, so you don't miss anything good. And hopefully I will see you soon on the next episode of Sound Advice.